ASK Aviation School.
Welcome to ASK Aviation School. Today we are going to discuss one of the most lethal aviation hazards associated with thunderstorms, that is microburst and wind shear.
Between 1970 and 1994, hundreds of passengers lost their lives in sudden, violent commercial airline crashes that occurred just moments before landing or right after takeoff. Investigators probing the wreckage consistently found perfectly healthy aircraft. The engines hadn't failed, the mechanical structures were intact, and there were no lightning strikes. To stay airborne, an airplane relies entirely on lift. This physical force is generated by the high-velocity air moving directly over the wings. In these specific crashes, functioning aircraft were suddenly stripped of that airflow. Within seconds, they lost the physical ability to fly, plummeting to the earth without any visible cause. Flight data recorders and surviving pilots reported a strange sequence of events just before impact. The data showed a massive, unexplained spike in the aircraft's airspeed. Seconds after that initial surge, the airspeed would vanish. The plane would suffer a catastrophic loss of lift and immediately plunge into the ground. Meteorologists eventually identified the culprit as a weather phenomenon known as a microburst. Because this localized column of sinking air was completely invisible to traditional weather radar and the human eye, flight crews were flying directly into a deadly aerodynamic trap they could not see. A microburst begins inside a thunderstorm. It pulls in dry air, rapidly evaporating falling rain. This violently cools the air pocket, creating negative buoyancy. The incredibly heavy mass plummets straight down, hitting the ground and spreading out into 150-mile-per-hour straight-line winds.
All right, let's dive right into a critical ground school lesson. Today, we're going to break down one of aviation's most dangerous and invisible threats, the microburst. And look, this isn't just about theory for an exam. This is about survival skills for the most critical phases of flight. So, here's our game plan. We'll start by understanding the stakes. Then we'll deconstruct this threat, from its physics to what you'll actually see and hear in the cockpit. We're going to cover how the aircraft behaves, and most importantly, the absolute non-negotiable escape maneuver. Then we'll wrap it all up with the key takeaways that are going to keep you safe. You know, to really grasp why this topic is so incredibly important, we have to look at the lessons learned from those who flew before us. The crash of U.S. Air Flight 1016 back in '94 was a harsh, tragic reminder of the raw power of a microburst, and it reinforced why the training we're covering today is absolutely mandatory. I want you to just imagine this for a second. You're on final approach, and your aircraft's performance changes by over 60 knots in just 15 seconds. That is the reality of a microburst. It's a sudden, violent shift in the air mass that can literally overwhelm an aircraft if it's not handled correctly and, more importantly, immediately. Okay, so let's define our terms so we're all on the same page. At its very core, wind shear is exactly what it sounds like, a rapid change in wind over a very short distance. It can happen vertically, as you climb or descend through different layers of air, or it can happen horizontally, like when you're flying through a frontal boundary or the outflow from a storm. Now, the most dangerous form of wind shear, the one we're really focused on, is the microburst. Think of it as a highly concentrated, violent downdraft that just hits the ground and explodes outwards. And make no mistake about it, this is the most severe threat you can possibly face at low altitudes. Period.
To defeat a threat, you first have to understand it, right? So let's break down the science behind how these things actually form and behave.
The entire life cycle of a microburst is terrifyingly brief. We're talking just 5 to 15 minutes start to finish. It all begins with formation, where things like evaporation and precipitation create a really powerful downdraft. Then that column of air impacts the ground, and finally it dissipates, spreading outwards and creating that intense, dangerous wind shear. Now, it's crucial to know they come in two main flavors. Wet microbursts are what we often picture, hidden inside a heavy rain shaft from a big thunderstorm. But dry microbursts, well, they can be even more insidious. They happen when precipitation evaporates before it even reaches the ground. You know, that phenomenon called virga. This evaporative cooling acts as the engine, creating a powerful downdraft with very few, if any, visual cues at the surface. Let me be clear, both are equally dangerous. Okay, let's move from the textbook to the flight deck. We've covered the what and the why. Now let's talk about the how. How do we recognize that we're about to fly into one or that we're already in one? Before any automated warning ever goes off, your primary instruments are going to be telling you that something is very, very wrong. These are your first clues. Any uncommanded deviation, more than 15 knots of airspeed, 500 feet per minute vertically, 5 degrees of pitch, or a dot on the glide slope is a huge red flag. Your autothrottles might be going nuts trying to compensate. This is the moment you have to be hyper vigilant. Fortunately for us, modern avionics give us a powerful advantage.
Engineers developed a ground-based monitoring network known as the Low-Level Wind Shear Alert System. By installing a perimeter of pole-mounted sensors around an airport, the system actively measures wind speed and direction. If a sudden wind boundary crosses these sensors, a master alarm immediately alerts air traffic controllers. To give pilots their own layer of defense, developers turn to the aircraft's internal weather radar, located inside the nose cone.
The first line of defense is the Predictive Wind Shear System, or PWS. It basically uses the weather radar to scan ahead of the aircraft, analyzing air movements to detect a microburst before you fly into it. And this is the alert you simply cannot ignore. On approach, the PWS will give you this clear, unmistakable voice command, and it'll pair it with a red WS ahead on your PFD. This is not a suggestion, folks. It is a command to execute an immediate go-around. You have just been given the gift of time, so use it. Now, if you don't get a predictive warning, or if the event just develops right on top of you, your next line of defense is the reactive wind shear system. This system doesn't look ahead. It analyzes the aircraft's real-time performance. As soon as it senses a performance drop that's characteristic of wind shear, it triggers an immediate warning. This is the sound no pilot ever wants to hear. This urgent, repeated alert, combined with a bold red wind shear message on the PFD, means you are in it right now. There's no time for analysis. There is only time for immediate memory item action.
So what is actually happening to the aircraft during those critical seconds? Let's walk through the dangerous sequence of performance changes you are going to experience.
Flying into a microburst is a 3-act tragedy if you're unprepared. First, you hit the outflow, which feels like a strong headwind. Performance increases, airspeed jumps up, and you might even have to pitch down. This is the ultimate deception, because right after that, you enter the downdraft, and the bottom just falls out. And finally, as you exit, that headwind instantly becomes a massive tailwind, destroying your airspeed and lift at the absolute worst possible moment. All right, now for the most important part of this entire discussion, the precise, standardized escape maneuver. There's a reason this is a memory item. These actions have to be instinctive. The moment you get a warning or recognize the signs, thrust levers to toga, full power, disconnect the autopilot and pitch smoothly towards the flight director's escape guidance, about 15 degrees nose up. Now, this is crucial. Do not change your configuration. Touching the gear or flaps will only increase drag when you need every ounce of performance. And finally, keep the wings level to direct all available energy into the climb.
I cannot stress this enough. Hesitation is the single greatest risk factor in a wind shear encounter. This procedure is designed to be executed instantly. You have to trust your training, trust the warnings, and act now.
Okay, let's recap and really reinforce the most vital points from this briefing. These are the numbers and concepts that you have to commit to memory.
Remember the sheer power we're dealing with here. A microburst can generate downdrafts of up to 6,000 feet per minute. That is a descent rate that can exceed the climb performance of many aircraft, especially when you're low and heavy. And the horizontal component is just as violent. The change from headwind to tailwind can exceed 100 knots. This is the performance shear that leads to a catastrophic loss of airspeed and lift if that escape maneuver isn't flown perfectly. Ultimately, it all comes down to this. The technology in your flight deck provides the warnings, but it is your swift recognition and your disciplined, immediate application of the trained procedure that ensures survival. Technology is an aid, but the pilot is the final safety barrier. So we'll end with a question to leave you with. You're on short final, and that wind shear alert erupts in the cockpit. In that instant, with everything on the line, what is your very first instinctive action? Because the answer to that question will determine the outcome. Stay sharp out there.
ASK Aviation School.